Hello, grade 10s, and a warm welcome. My name is Mr. T, and I'm excited to be presenting to you a lesson on graphs, commonly known as functions. There are mainly four graphs that you need to have a full understanding of at grade 10. The first one is a straight line. The name is suggestive. It's a straight line. The second one, it's a parabola, which is also known as a quadratic graph. The third one is a hyperbola. The fourth one is an exponential graph. We're going to go straight into a straight line. And just to give it more context, we start by stating the general equation of a straight line. Any straight line is given in one of these two forms at grade 10, depending on the textbook that you're using. One will say y is equal to mx plus c. The other will say y is equal to ax plus q, all of which are the same. Again, I said it depends on the textbook that you're using. We start off by identifying our unknowns. We start off with m. Our m represents the gradient or the slope of our straight line. And that is calculated by saying a change in y over a change in x, y2 minus y1 over x2 minus x1. Please do not make a mistake of saying x2 minus x1 over y2 minus y1. It's a common mistake, so please watch out for that one. Your c value, which is just a constant, represents your y-intercept. Your y-intercept. Again, that y-intercept can be represented or explained as a vertical shift of your straight line. But let's move straight to the other side, where our a is the same as the m. That's your gradient. Your q value, that q value, represents vertical shifts, which is the same effect of that c, vertical shifts, by q units or c units in the direction of its sign. If it's negative, it's c units downwards. If it's positive, it's c units upwards. We move on to a scenario where you're given y is equal to mx plus c. If you're given y is equal to mx plus c and you're told that your m is greater than 0, in other words, it's positive, it's got a positive gradient. If you were to sketch a graph there, you'd expect your graph to have a positive gradient. In other words, it must be slant to the right of your y-axis. That's very important. So any straight line which is slant to the right of the y-axis depicts a positive gradient. Similarly, if the graph or the gradient has a negative gradient, if the straight line is a negative gradient, it will be slant towards the left, just like that green line. Those are two important concepts that you should conceptualize as you're looking at any straight line function that you're given. We move on to a parabola, and we start with a general equation as well, which is y is equals to f of x, which is equals to ax squared plus q. The one thing that we've just introduced now is the concept of a function of x, that part. You need to know that f of x is the same as your y, is the same as your y. So you don't need to worry about that. It's just treated as if it's a y. So to define our values, our unknowns a and q, starting with a determines the shape of your graph. If your a is positive, you're going to have a graph which is concave up. Generally speaking, we say it's smiley. The reverse is true. If your a is negative, the graph is concave down. In other words, it's sad. Then let's look at the effect of q on the graph, that q. The concept of Q revolves around vertical shifts. If it's a positive Q value, it means your parabola will shift by Q units upwards. If it's negative, the opposite is true. It moves down by Q units. Very important. We move on to an illustration where if you're given that graph that you're seeing, immediately you should recognize that your A value for that graph is positive. Why? Because it's concave up. But the concept that we want to explain is a concept of the following special points, starting with the turning point. The turning point happens to be the lowest point or the highest point on any parabola. If you are given a function like f of x is equal to ax squared plus q, we've already stated that the q value represents the shifts of your graph up or down. We move on to the x-intercepts. Right? There are two of them. So it's x-intercepts. So these two are the x-intercepts of that graph. They represent your solutions when you solve for your parabola. We move on to another concept, which is a concept of the axis of symmetry, which is represented by a broken line. And in this specific context, our axis of symmetry is given by the equation x is equal to 0. Where is the 0 coming from, one might wonder. The 0 happens to be the x coordinate of your turning point. So these are the coordinates of the turning point. 0 is to q. So the 0, the x value, that x value is the one that led to that equation, your axis of symmetry, which represents a line, a broken line, which divides your parabola into two halves. Moving along to another concept, we move on to the concept of domain. Domain represents the x values or assumes the x values which underpin that graph. So x is an element of real numbers, is true to the graph that you're seeing on the screen right now. In other words, your x values range from minus infinity up to positive infinity. When it comes to the range, however, your range in this specific graph is y is greater than or equal to q. Again, one might wonder, where is the q coming from? The q happens to be the y value of your turning point, that q, or the q that we got from the equation, that q. So that determines the lowest or the highest value depending on its shape. If it was concave down, then we would have to reverse it to y less or equal to q as well. I hope you enjoyed that lesson. Until next time, bye-bye.